Okay, so we're going to talk about hyperbolas. Hyperbolas are kind of like two parabolas with the round parts facing each other. So I always say two parabolas with their butts facing each other. But either way, you can think of it either way. So they always face each other so they can go horizontal or they can be vertical. Okay, so if it opens left and right, that means it's horizontal. If it opens up and down, that's vertical. And instead of a constant sum, like with ellipses, hyperbolas have a constant difference. That's where you take the distance from the point to your first focus and the distance from your point to the second focus, and you subtract those, but then you take the absolute value. So remember, absolute value is the distance from 0. That's why when we take the absolute value of something, it's always positive. All right, so let's begin. I'm going to first find the distance between my first focus and the point on my hyperbola. And remember, this is not hyperbola, it's hyperbola. Kind of like hyperbole in English, but this is a hyperbola. All right, so I will find the distance between those two using the distance formula. So that's where I take my x's and subtract them, negative 5 minus 4, and I square that, plus I take my y's and subtract them, 0 minus 0 squared. And then I'm going to add the distance, not add, subtract. Subtract the distance between my second focus and that same point. So that gives me 5 minus 4 squared plus 0 minus 0 squared. And then I have to take the absolute value of that. So if I find this distance here, this is going to be the square root of 81 minus, sorry about that, malfunction, minus, if I work this will be the square root of 1. So I get the square root of 81, which is 9, minus the square root of 1, which is 1. 9 minus 1 is 8, and the absolute value of 8 is 8. So the constant difference would be 8. I'm only giving you one of those because we've kind of done similar things with the constant sum. And I want to go ahead and move on. All right, so here are your general equations for hyperbolas. This is with a center at 0, 0. But I want to point a couple of things out. First off, let's look at these two up here. Hyperbolas always have a minus sign in between the x and the y. And if you'll notice, these look really similar to ellipses, except it has a plus sign. So we still have the a's and the b's. All right. So the other thing that's different is that x is listed first here, but it's listed second here, and y is listed first. This is the biggest difference between an ellipse and a hyperbola. If x is before the minus sign, that makes this a horizontal hyperbola. If y is before the minus sign, that makes this a vertical. A is no longer just the biggest number. All right, so I'm repeating that. If x comes before the minus sign, it's horizontal. If y comes before the minus sign, it is vertical. A is no longer the biggest number. It's always the one that's in the front. So if you'll notice, it's in the front, it's in the front. When the center is no longer at 0, 0, it's still in the front, still in the front. And B is the one at the back, still equal to 1. So when we actually get to 10-6 and we have to identify different types of conic sections, it's going to be important for you to realize that hyperbolas have a minus and ellipses have a plus, and the differences between those two. If you learn this now, it makes things way easier for you later. Okay? So, instead of having a major axis and a minor axis, we have what we call a transverse axis. That has the vertices of your hyperbola and the foci. Okay? The conjugate axis, which would be like your minor axis of an ellipse, contains the covertices. All right? Instead of using a squared minus b squared equals c squared, we actually use the Pythagorean theorem. A is still your vertex, B is still your covertex, C is still your focus. A is always the one in front, and your transverse axis is identified by the front variable, which we just talked about a while ago. So let's practice writing equations with a center at 0, 0. I'm not going to give you any that have a center that's somewhere else. All right? So let's take a look at these. These work exactly like ellipses. So I'm going to look at my vertex here. I have a vertex at 5, 0. And the non-zero number is in the x spot. I also know that the vertex tells me the A, so this is also going to be my A. My covertex is the non-zero number is in the y spot, and I know that the covertex identifies the C. In order to write the equation of a hyperbola, I have to have A and B for the bottom. But I do know that since the vertex is always on my transverse axis, and that is this one right here in the x spot, that means this is a left and right. So x squared will be listed first. And remember, another way to think of this is A is identified in the x spot, so that means that it's going to have to be the one in front. All right, minus y squared over something equals 1. Well, I already know that a squared is always the number that's in front up here. So I'm going to take and square this. 5 squared is 25. But I still need b squared for underneath this part right here. So I will use that Pythagorean theorem. A squared plus b squared equals c squared. Well, I already know that a squared is 25. I don't know what b is. I'm trying to figure that out. And I know that c squared, that would be 3 squared, is 9. So I'm going to solve for b here and subtract the 25. So if I subtract 25, 9 minus 25 is going to give me sorry, had another malfunction, mainly because I did something wrong. So let's go back and fix it. The covertex is not my C, it is my B. See, teachers make mistakes too. All right. I bet you guys were sitting there thinking, Miss Archer, you've got to fix that. Am I right? I think I'm right. All right, so this is my B, so I don't need to do this because I already have my B. So b squared, that'd be 3 squared is 9, and this is my equation. So why don't you go ahead and erase this stuff here so that you don't confuse yourself later because I was doing the problem wrong. All right, let's move on. All right, so my vertex, the non-zero number is in the y spot. Okay, and I know that my vertex always identifies the A. And my focus always identifies the C. There we go. And that's also in the y spot. But I don't have my B, so I know that A is 12. I don't know B. And C is 20. So since A is going to be the 12, that means that's going to go underneath the y because it's in the y spot. And that means y is going to be first because A is always first. So I have y squared over something minus x squared over something equals 1. And I know that a squared has to go underneath the y. So 12 squared is 144. So I'm going to use my Pythagorean theorem to identify the b squared so that I can put that underneath the x. So a squared, I know that's 144. And I know that c squared, 220 squared, is 400. So I'm going to go ahead and subtract the 144. So I get b squared equals 256. And remember, you don't need to square root that because you actually need b squared to go underneath here. So this is very similar to what you did with the ellipses. All right, now let's do a few graphing problems. 3 to be exact. All right, so if you take a look at this, remember we decided that it matters what's in front on these. So if I look at this, y is in front of the minus sign. So I know that this is going to be a vertical hyperbola. All right, what that means is that it's going to open up and down. All right, I'm going to identify my center. Well, I get the x from the x and the y from the y. So if I look right here, there's no number with this x, so that's going to be 0, comma. There's no number with this y, so 0. Next, I need to identify a and b. Well, a is the square root of whatever number is in front. Remember, with an ellipse, it's the bigger number. With a hyperbola, it's whatever's in front. So I'll take the square root of 25. That gives me 5. And it's underneath the y, so that means I'll go up 5 and down 5. B is going to be the square root of the other number, the one at the back, so square root of 36, which is 6. And since it's underneath the x, that means we will move left 6 and right 6. All right, so we're going to start with our center, and these actually graph a little bit different. It starts out the same as an ellipse, but then we use things in a different way. So please pay close attention to the way I graph. So we're going to start at 0, 0. Put a dot there. All right, from that center, we decided that we were going up 5, down 5. 1, 2, 3, 4, 5. And down 5. 1, 2, 3, 4, 5. And then from the center, we're going left 6 and right 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. Now, instead of drawing a circle in, what this is going to do is help us create our hyperbola. So what you're going to do is you are going to make a box out of all of these dots on the outside. So I'm just kind of connecting the dots to make a box. All the way around. All right. Now, the whole point of the box is because we have to put some asymptotes on our graphs. I know how much you guys like asymptotes. Now remember, asymptotes are imaginary type lines that are a guideline. And make sure that you use your entire graph when drawing these, because some of these hyperbolas are really fat, and so you need to use your whole graph for them. So what's going to happen is, do you see this corner up here and this corner down here? What we are going to do is we're going to draw a dotted line. Wow, that's really terrible. I think I'll just draw it by hand. We're going to draw a dotted line that goes all the way from this corner to this corner, but make sure it extends out. So draw you a dotted line. I realize that these will not be perfect, but it should go right through your center. And you have to extend past your box. Alright, once you get one side, you have to do the other. So, draw this dotted line. If you'll use a ruler, that will be much better. Now, since this opens up and down, that means that the dots on the top and the bottom will be your vertices. So let's put a V by those. And that means the dots on the side are your co-vertices. So let's put a CV there. Okay? So when you draw this in, please pay careful attention. You start at your vertex, and you are going to sweep out and approach this asymptote. You don't touch or cross the asymptote, right? And you do the same thing to this side. Up, and then you got to do the same thing down here at the bottom. Start and sweep. And I hope yours looks better than mine. Start and sweep. So you should have one that opens up and one that opens down. Now I'm going to ask you to identify your co-vertices and vertices by labeling them. So this vertex is at 0, 5. This vertex is at 0, -5. This co-vertex is at 2, 3, 4, 5, 6, 0. And this one is at -6, 0. Alright? So main things to remember, you start off just like an ellipse, make the box, put your guidelines in with your asymptotes, label your vertices and co-vertices, and draw everything in. Alright, let's do another one. So if we take a look at number 5 here, first thing I'm going to do is decide which way this is going to open. Since y is listed before the minus sign, that makes this vertical. That means it's going to open up and down. Okay? And let's identify our center. You always get the x from the x and the y from the y. So this is going to be +1, comma, -5 as your center. Let's identify your a. A is always the number in front, so I will square root that 9. The square root of 9 is 3. Since 3 is underneath the y, I will go up 3 and down 3. B is the number that's underneath here. Well, this is over a 1, right? So if I square root 1, I get 1. Since that's underneath the x, that means I will move left 1 and right 1 from the center of my hyperbola. Alright, so let's go up and graph that. So 1, -5. We decided we were moving up 3 and down 3. 1, 2, 3. 1, 2, 3. And we were going to move left 1 and right 1. So left 1, right 1. It's going to be a little one. And then draw your box in. Maybe you can see that a little bit better if I... Now these are not solid boxes, okay? Alright, once you get that on there, you're ready to draw in your asymptotes. Remember, you go diagonally, corner to corner. Make sure you go through your center. Extend past. It'd be easier if you just use a ruler. Now we decided that this opens up and down. So that means the top and bottom will be your vertices, and the two on the left and right will be your co-vertices. So label those. And then you need to name your points. So this vertex is at 1, -2. And this vertex is at 1, -3, 4, 5, 6, 7, 8. This co-vertex is at 2, -5. And this co-vertex is at 0, -5. Make sure there's a label, and you can put them somewhere else. You don't have to put them on your graph. They're a little bit harder to see. So you want to make sure you draw this in. So start with your vertex and sweep towards. These are not V's, remember, so make sure that they're curved. All right. And there's that one. All right, last one. Number 6. So let's decide which way this is opening. X is in front of the minus sign, so this one will actually be horizontal. So that means it's going to open to the left and to the right. Okay? Identify your center. Remember, you always get the X from the X and the Y from the Y. So this would be a +2, comma, -3. It's the opposite signs. A is always the number in the front, so we'll square root the 16. That gives us 4. Since that's underneath the X, that means I will go left 4 and right 4. B would be the number at the back here, so the square root of 49, which is 7. Since that's underneath the Y, we will go up 7 and down 7 from the center of our hyperbola. So let's graph this. 2, -3. 2, -3 is our center. We're going to go left 4, right 4. 4. 1, 2, 3, 4. And up 7, down 7. 2, 3, 4, 5, 6, 7. And 2, 3, 4, 5, 6, 7. And then you're going to make your box. So really, once you do all your dots on the outside, you don't really use the center anymore, except as a guideline of where to put your asymptotes. Alright, once you get your box drawn, you're going to draw in your asymptotes from corner to corner and make sure you extend. Oops. Sorry about that. Make sure you extend past your corners. Do both sides. Mine is a little bit crooked. Sorry, I'm not the best at this. Alright, we said this opens left and right, which means the sides will be your vertices, and the top and bottom will be your co-vertices. So you can go ahead and draw that in. So you start with your vertex here. This one's going to be a really wide one. So you should sweep and start your vertex and sweep. You're going to do the same thing on this side. Make sure it's rounded. It's just so hard to draw these on here. And then you're going to label these. So this point right here is 6, -3. The vertex on this side is -2, -3. My co-vertex up top here is 2, 4. And my co-vertex on the bottom is 2, -10. And there you have it. That's how you graph hyperbolas. So really similar to ellipses, except you got to do the whole box thing and everything else. So I would prefer on your homework that you actually tell me your vertices down below in your work and your co-vertices. It would be easier for me to see.